Okay, let's finish spring also. Spring in series and parallel. Write down. Springs in series and parallel. Write down. Springs in series and parallel. Okay. Spring is a very important, right? Spring is there in a simple harmonic motion also, correct? And it is there in Newton's laws of motion also, and work for energy also, right? uh, Energy is stored in spring. What is the formula? You know any formula? Potential energy half kx square. Very good. Half kx square. In work for energy, we'll discuss. Okay. Now, what do you mean by series and parallel? So, when connected end to end, note down, when connected end to end, end to end, like this. This is one spring, and this is second spring. They are connected. So both are massless, but spring constants are K1, K2. Massless springs, spring constants K1, K2. Suppose this is the wall. So spring one left end. Where is the left end? It is connected to wall. Spring one right end. It is connected to spring two, and this is the other end of spring two. Now you are holding it and pulling it. You are pulling it. So what force you are exerting it? F. So both are elongated. Both are elongated. So what is the elongation in this spring? X1. What is the elongation in this spring? X2. So what is the spring force in this spring force? K1 X1. What is the spring force in this? K2 X2. Okay. So spring force in 2, spring force in 1. Now what is the net force? What is the net force on spring? Suppose this is the spring. Suppose this is the spring. What is the net force? Suppose if you exert force F here. So what is the force here? F. Okay. Both hands same force. So what is the net force? 0. Net force is 0. So force here is F. So what is force here? F. So what is force here? F. So force here is F, force here is also F, here also, everywhere force is same. Okay. So tension is same. So spring force is same, note down. So in a series, note down. In series, in series, spring force are equal. In series, spring force are equal. Okay. So what is the relation between x1 s2? So fs1 is equal to fs2. So what do you write? K1 x1 is equal to K2 x2, and both are equal to F. Note down, both are equal to F. So what is x1? Elongation in spring 1, F by K1. What is elongation in spring 2? F by K2. Correct? If I ask what is the ratio What is the ratio x1 by x2? Tell me, what is the ratio? K1 by K2 or K2 by K1? K2 by K1. Very good. K2 by K1. Note down. X1, X2 and ratio K2 by K1. Which spring elongate more? The one having more spring constant or less spring constant? So X is inversely proportional to K. X is inversely proportional to K. F is same. F is same. So inverse. More K means more strong. More strong means elongation less. Elongation less. Strong spring has less elongation. Strong spring means K more. What do you mean by strong spring? K is more. More value of K means strong spring. Okay, so elongation is less. Elongation is less. Okay, fine. So now suppose two vertical springs are there. Now you answer this. Suppose one spring, another spring, and block M attached. Spring constant K. This is spring constant 2K. Tell me, what is the elongation in this spring? What is the spring force? What is the spring force? Tell me. Here, what is the force downward? Mg. So spring force is also Mg. This block downward is Mg. Spring force is upward. So whatever is elongation in this, that is into 2K, that is a spring force. So what is elongation in this? Spring force by spring constant. What is elongation in this? Spring force by, understood? Spring constant mg by 2K. If three springs are there, one spring, two spring, third. Okay. Suppose block is M here. This is K1, K2, K3. So what is elongation in this? Mg by K1. What is elongation in this? Mg by K2. What is the elongation in this? Mg by K3. Correct? Good. So they are in series. So force is same. Force is same. Force is same. Now equivalent spring constant. Next you write down equivalent spring constant. What is equivalent spring constant? Suppose two springs are there. Two springs are there. Okay, like this. Two springs are there. If you replace these two spring with single spring, one spring. So what is the spring constant of that? That is known as equivalent. Equivalent spring constant. So what is equivalent spring constant? Note down. If combination of springs is replaced with single one single spring, and same force exerted, what is the spring constant of that single spring? What is spring constant of single spring. Okay, clear? So suppose now two springs are there, suppose. So we have discussed this. Let's take horizontal one. Let's take horizontal. Now force here is F. This is K1, this is K2. Now replace it with single spring and force is F. So what is the elongation in this spring? X1. What is the elongation in this spring? X2. So this spring also elongated by same amount. This spring also elongate, okay, it will also elongate by same amount. So what is elongation in this? X1 plus X2. X1 plus X2. When two different springs, what is the elongation in this? X1. What is the elongation in this? X2. Okay. See, I will tell. When there is no force, what is going on? When no force, these are the springs. So both are natural state. Both are natural state. So let's say this is point A, B and C. Suppose this is point A, point B, point C. There is no force here, no force. So both are natural state. So spring 1, spring 1 natural state, natural length. Spring 2 also natural length. Now suppose you exert force here. Point C will shift right. Point C will shift right. So what about point B? B will also shift right. So it will be like this. Now C is here, C is here, B is here, A is here. Any shift in A is not shifting. C is shifting, B is shifting. Are you getting or not? Okay. So this is, what is this? How much is this? Tell me. How much B is shifting? X1. Okay. And how much C is shifting? Tell me, how much C is shifting? B is shifting how much? X1. That is elongation in spring 1. Correct or not? Are you getting? Elongation. Elongation in spring 1 how much? X1. So B is shifting how much? X1. A is not going anywhere. Now B is shifting right side and total elongation in B's second spring is X2. So how much C will shift? This will be, tell me. B is suppose, suppose B is shifting right side by X1. So C will also shift right side by X1. And further how much? X2. Because elongation is how much? X2. So C will shift how much? X1 plus X2. Are you getting? See, look here. This is a natural state. Now you observe what I am doing. Are you getting? Left, right, okay. How much left is shifting? How much left is shifting? This left finger, how much it is shifting? X1. And right finger also shifting right side. Correct or not? Now what is the initial length between these two? Natural length. And what is the final length? Natural length plus X2. Final length is natural length plus X2. Are you getting or not? Suppose initial length is L. So what is the new length? L plus x2, correct? So you can remember this, just copy this. B, suppose elongation in first spring is x1, so B is shifting how much? X1. And elongation in second spring is x2, so how much C is shifting? X1 plus x2. Okay, clear? Okay, so suppose first spring, second spring, they are in series. So they are in series. So what is the K equivalent of single spring? So for elongation in first is x1, elongation in second is x2. So what is the elongation in equivalent? X1 plus x2. Okay. Now force is same. So what you write force here? Tell me. F is equal to what you write? F is equal to what you write? Tell me. K1 x1. And what you write here? F is equal to K2 x2. Very good. And what you write F here? F is equal to K equivalent into x1 plus x2. K equivalent x1 plus x2. Clear? Note down. Note down. Copy this. Now find x1 from here. What is x1 from here? F by k1. Put it here. So we will write so I am writing here. So F will be K equivalent x1 plus x2, and x1 is F by k1, F by k1 plus x2 is F by k2, F by k2. Easy, right? Now take F common. Take F common. 1 by k1 plus 1 by k2. Now this F cancel. So 1 is equal to K equivalent. Now solve this. K2 plus K1 by K1 K2. Now take it here. So what is the formula? K1 K2 by K1 plus K2 is equal to KQ. K equivalent is K1 K2 by K1 plus K2. And 1 by K equivalent. What is 1 by K equivalent? 1 by K1 plus 1 by K2. So it is same as resistance in parallel, right? If two resistance in parallel, how to find equivalent? Two resistance, electric resistance. 1 by R equivalent is 1 by R1 plus 1 by R2. Okay. Capacitors in series. Capacitors in series. How to find equivalent? Correct. 1 by C equivalent is 1 by C1 plus 1 by C2. So capacitors in series formula, springs in series formula. So springs are like capacitor or resistance. Springs, capacitors. Capacitor in series formula, like this same formula here also, right? So springs and capacitors are same. You memorize like this, okay? Formula is same. They are same, no. Concept is entirely different. Physics is different. Springs we use in truck, buses. Capacitor we use in computers. Correct or not? Meaning is different. Just to memorize the formula. Okay? Just to memorize the formula. 1 by K equivalent 1 by K1 plus 1 by K2. 1 by C equivalent is 1 by C1 plus 1 by C2. Capacitors in series. Springs in series. So if you have 3 springs or n springs, tell me what is equivalent. Okay, 3 springs are there. K, 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 all are K. What is K equivalent? 1 by K equivalent, tell me. 1 by K plus 1 by K plus 1 by K. So 3 by K. So what is K equivalent? K by 3. So suppose you have 1, 2, 3, 4 and so on. N springs. N identical springs. N identical springs. All are K, K, all are K. So what is the K equivalent? K by N. If 3 springs, k by 3. 2 springs, k by 2. If 2 springs, k series, so k equivalent is k by 2. 2 identical springs in series, k by 2. 3 identical springs in series, k by 3. N identical springs in series, k by n. Okay, k by n. Okay, fine, clear. Okay, done. Note down. Identical spring in series is k by n. Okay. So now parallel springs in parallel. Note down. They are parallel. Now this is the common point. You are exerting force here. So elongation will be same. What is elongation in this spring? X. What is elongation in this spring? X. So basically both ends are common. Both ends are common. Right end of spring 1 and right end of spring 2 same. Left end is also same. Left end of spring 1, left end of spring 2 same. So now this right end you are exerting what force? F. So both springs elongate. What is same for both? X. Elongation is same. Note down. Parallel means same elongation, equal elongation. Note down. Same, equal elongation. Series, what is same? Series, force is same. Correct. Force is same. Parallel, what is same? Elongations. Remember, x. Okay, x is same. Now you see this this force here. Right side, what is the force? F. Left side, what is the force here? Tell me. This spring will pull it. What force it will exert? K1x. And this spring will pull it left. What force? K2x. Now K1x left, K2x left, and F right. So, and it is balanced. Force is balanced because spring is massless. Okay, spring is massless. Spring is massless, right? So this point is also massless. So balance forces are balanced. So what is F? Add K1x plus K2x. X you can take common. So F is equal to K1 plus K2 into X. Okay. F is equal to K1 plus K2 into X. So let's solve one question. Suppose, see, suppose this is the spring constant K and this is the spring constant 3K. Now I am exerting force F here. So tell me, what is the how to find elongation? So what is elongation in upper spring? X. Elongation in lower spring? X. So how to solve? F is equal to Kx plus 3Kx. Total 4Kx. So what is X? F by 4K. F by 4K. Clear? What is same? What is same? X. X is same. Okay, clear? Parallel X is same. Elongation is same. So spring force in this plus spring force in this is equal to F. Fs1 plus Fs2 is equal to F. Fs1 plus Fs2 is equal to F. So one numerical also you can solve. Now I am giving K value. So suppose now three springs I am giving. This is 100 Newton per meter. This is 200 Newton per meter. This is 300 Newton per meter. And right side you are exerting 10 Newton force. 10 Newton force. So they are in series or parallel? Parallel. So what is same? Elongation same. So elongation in this is x, elongation in this is x, elongation in this is x. So how will you find x? How will you find x? K1x, K1x. So 100x plus K2x, 200x plus K3x, 300x is equal to 10. So the total tell me. 600x is equal to 10. So what is x? 10 by 600, correct? So you can use this. So f is equal to k1x plus k2x plus k3x. Okay, understood? And so on. So what is x? F by k1 plus k2 plus k3 and so on. F by k1 plus k2. Okay, understood? F by k1 plus k2 plus k3. So 1 by 60 meter or 100 centimeter by 60. So 10 by 6 centimeter. 10 by 6 centimeter means 5 by 3 centimeter. So 5 by 3 centimeter means 1.67 centimeter. So all three springs same elongation, same elongation, same elongation. Okay, same elongation. So how much elongation? 5 by 3. Okay, clear? So parallel means elongation same. Remember, series means force same. Series means force same. Now equivalent. Let's solve equivalent. So equivalent. Now these are the two springs K1, K2. Force is F. Now replace it with single spring. Same force and same elongation. What is elongation in this spring? X. What is elongation in this spring? X. So now this is K equivalent, single spring. What is the elongation? X. Okay. So now what is F here? K1x plus K2x. And what is F here? K equivalent into X. K equivalent into X. Now F is this and here F is this. So this equal. So tell me what you write. K1x plus K2x is equal to K equivalent X. So x cancel. X cancel. So K1 plus K2 is equal to K equivalent. K1 plus K2. Are you getting? Series of parallel? Parallel. Parallel means K1 plus K2. Capacitor in parallel. Tell me. Capacitor in parallel. What is the equivalent? C equivalent. Capacitor in parallel. So capacitor in parallel. Capacitor in parallel. Tell me. C1 plus C2. Good. So capacitor and springs. Same or different? Same. Capacitor in parallel, spring in parallel, same formula, springs in parallel, K1 plus K2, capacitors in parallel, C1 plus C2. Okay, clear? So remember this, note down. So K equivalent is equal to K1 plus K2. Parallel means what is same? Everyone tell me. Elongation same. Correct, good. And K equivalent is K1 plus K2. So suppose two identical springs are there, K. Two identical springs. So what is K equivalent? Tell me. 2k, very good, 2k. Now three identical springs. So k plus k plus k, 3k. Now n identical springs, n identical springs. Tell me, k equivalent, nk. Okay, k equivalent, nk. Two identical, 2k. Three identical in parallel, 3k. N identical in parallel, nk. Okay, clear? So n identical in parallel, nk. Now I will give you mixed combination, series and parallel both. Now you solve this. Suppose two springs in series and third spring in parallel, and force is acting here. This is k, this is 2k, and this is also k. So k1 is, this is spring 1, k1 is k, spring 2, k2 is 2k, spring 3, k3 is k. So tell me what is the, first you tell me what is the equivalent. What is the equivalent? Tell me. What is equivalent of these two? Series. Series, what is the formula? K1, K2 by K1 plus K2. Are you getting? Series. Series. So what is equivalent of these two? K2K. K into 2K divided by K plus 2K. So 2K square by 3K. K cancel. 2K by 3. Very good. So this is 2K by 3 and this is K. So again draw another diagram. Now you have two springs. This is 2K by 3 and what is this? K. Equivalent of these two, 2K by 3, this is K. Now they are in series of parallel. Parallel. So what is K equivalent now? Add 2K by 3 plus K. How much? 5K by 3. Okay, 5K by 3. Okay, clear? Note down. So, okay, fine. So 5K by 3. Now you solve this. Next question. So 2 in series, third in parallel. Now I will give 2 in parallel, third in series. Now you solve this. First you tell what is K equivalent. This is K, this is 2K and this is K. 1, 2, 3. Spring 1, K1 is K, spring 2, K2 is 2K, spring 3, K3 is K. So first you tell me what is the combination of these two. Combination of these two. Series or parallel? Parallel. So what is the equivalent of these two? Parallel means what is the equivalent of these two? 3K. Very good. And then K. Now 3K and K series. So what is the equivalent? Use this type. K1 K2 by K1 plus K2. K1 K2 by K1. So what you write? 3K K divided by 3K plus K. 3K plus K. So 3K square by 4K. Okay. 3K by 4. Note down. 3K by 4. Note down. 3K by 4. 3K by 4. Okay, clear, understood. So, okay, fine. So here two springs in series, third in parallel, two spring parallel, third in series. Okay, clear. So two springs in parallel, so K1 plus K2, so K plus 2K. Now 3K, 3K K series. So K1 K2 by K1 plus K2. Okay, 3K by 4. 3k by 4. Now let's go back to previous question. What is the elongation in both? Come back here. Now elongation in these two same. Suppose elongation in this is x1. So no, what is same for both? Series what is same? Force. Very good. So what is elongation in this? x2. So what is elongation in this? x1 plus x2. Yes, ma'am. Yes, ma'am. Okay, okay. Go. Hmm. Go. Who? Name? Come, go. So elongation in this, let's say x3, suppose. Elongation in this is x3. What is elongation in this? x1. Elongation in this? x2. Elongation in this? x3. So now this force are same. So suppose here force, now you have to find x1 and x2. Okay, so this force is F1 and this force is F2. So F1 plus F2 is equal to F1 plus F2 is equal to F, and F1 can be written as Kx1, F2 is Kx3 is equal to F. What is relation between x1, x2 and x3? So how much this is shifting? This point shifting how much right side? This point shifting how much right side? x1. And elongation in this is x2. So this point is shifting how much? Suppose this is shifting 1 centimeter and elongation in second spring is 2 centimeter, suppose. So how much this will shift the right side? 3 centimeter, correct? This point is shifting right side 1 centimeter. This point is shifting right side 3 centimeter. So what is the elongation in this? 3 minus 1, so how much? 2. So how much this point is shifting? x1 plus x2. So what is relation between x3, x1 and x2? x3 is equal to x1 plus x2. Note down. x3 is equal to x1 plus elongation in this is x1, elongation in this is x2, elongation in this is x3. So x3 is x1 plus x2. So now x3 kx3 is equal to f2 and kx1 is f1. So now you solve this. F1 is kx1, f2 is kx3. This is f2, this is f1. Okay, actually it is f3. Actually I have written f2. You can write f3 here, no problem. You can write f3. So here also f3. So this force plus this force, f1 plus f3. f1 plus f3 is equal to f. So kx1 plus kx3 is equal to f. Okay. Okay, so find out. So x3 can be written as uh, x1 plus x2. So this is kx1 plus kx3, x3 x1 plus x2, x1 plus x2 is equal to f. So 2k x1 plus kx2 is equal to f. Now what is relation between x1 x2? Both forces are equal. So kx1 is equal to 2kx2, right or not? Kx1 is equal to 2kx2. So k cancel. So what is x1? 2x2. Now put here. Put substitute this here. So 2k into x1, 2k into 2x2 plus kx2 is equal to f. So 5 kx2, 2 into 2, 4, 4 plus 1. So 5 kx2 is equal to f. So what is x2? F by 5k. X2 is f by 5k. Okay, see this, note down. See, this is what is elongation in this? X1. What is elongation in this? X2. What is elongation in this? X3. So x1 plus x2 is equal to x3. You remember, first you remember this. X1 plus x2 is x3. And what is relation between these two? Force. Force same. So kx1 is equal to 2k x2. Kx1 is equal to 2k x2. K cancel. So what is x1? X1 is 2x2. So substitute it here. Here. Understood? Clear? Okay. Now x1 you got, x2 you got. So what is x1? Now x2 is f by 5k. So what is x1? 2x2. So 2f by 5k. And what is x3? How much x3? Tell me. x3 is x1 plus x2. So x3 will be x1 plus x2. x1 2f by 5k plus f by 5k. F by 5k. So what is the answer? X3? 3f by 5k. Okay, clear? So 2 series, 1 parallel. Okay, see once again. Series means what is same? Force. So kx1 is equal to 2kx2. Correct? So x1 x2 relation we got. X1 is 2x2. And here force is F1. Here what is the force? F3. F1 plus F3 is equal to F. So kx1 plus F3 kx3 is equal to F. And x3 is x1 plus x2. x3 is x1 plus x2. So kx1 plus kx1 plus x2 is F. So 2kx1 plus kx2 is equal to F. 3k. So then kx1 is 2x2. So cancel. x1 is 2x2. Okay, understood? Substitute it here. Put it here. We'll get this. Is 5kx2 is F. Okay, clear? Now solve this question. What is elongation in this? Come to this question. How to solve this? Now 2 parallel, 1 series. This one. What is elongation in this? X1. What is elongation in this? Same or different? Same. So, okay, x2 and x1, x2 equal. X1 is equal to x2. What is elongation in this? X3. So, now what force you are exerting here? F. So, what is the spring force in this? Same. So, kx3. Tell me, what is kx3? Kx3 is same as F. Spring force is F. So, kx3 so tell me what is kx3? Tell me. Kx3 F. So what is x3? F by k. Good. Now they are parallel. What is same? Elongation same. So x1 is equal to x2. Now see, look here. This knot like this. What is the force here? This kx1. Kx1. And what is the force here? 2kx2. And what is the force here? F. Okay, kx3 or F. Same thing. Kx3 and F same thing. And x1, x2 equal. So left side, right side same. So what do you write? Tell me. What is the net force left side? Kx1 plus 2kx2. So x1, x2 equal kx1 plus 2kx2 is equal to F. So kx1 plus 2kx1 is equal to F. 3kx1. 3kx1 is F. So what is x1? F by 3k. Okay, note down. F by 3k. Note down. F by 3k. Or you can find equivalent also. What is the equivalent? K and 2k, what is the equivalent? Parallel. K and 2k, what is equivalent? 3k. So you can solve like this also. 3k x1, okay, elongation is equal to F. So you'll get x1 is equal to F by 3k. F by 3k. Or you can solve like this also. This is kx1, this is 2kx2, kx1, 2kx2. Right side, what is the force? F. So this is equal to this plus this. This is equal to kx1 plus 2kx2 and x1, x2 equal. Okay, done. So note down. So x3 is F by k. X1 and x2 F by 3k. Okay, clear? Series and parallel. Okay, so done. So this spring is over. Just few more points we'll discuss. So series and parallel you revise. Okay, so note down. Now you answer this question. Spring constant K is cut in ratio 2:3. Now the two parts are connected in parallel. Two parts connected in parallel. What is K equivalent? Find K equivalent. Find K equivalent of parallel combination. Okay, that is a question. Okay, so you have a spring, right? The spring is there, it is cut into two parts. In what ratio you are cutting? 2:3. So yesterday we discussed Suppose you have a spring of a spring constant K, length L. I'm revising. If it is break into two equal parts, L by 2, L by 2. What is the spring constant of this? 2K. This 2K. Correct. Good. Now the same spring of a spring constant K, length L. Now it is break into what ratio? 2:3. So 2 plus 3, how much? 5. So what is the length? New length of this? 2L by 5. New length of this? 3L by 5. Very good. New spring constant? 5K by 2. This 5K by 3. Very good. Now these two springs are connected in parallel. Okay, spring of a spring constant K cut in ratio 2:3. Now they are connected in parallel. Now they are connected in parallel. This and this connected parallel. So what 2 5K by 2, 5K by 3. 5K by 2, 5K by 3. So it's parallel. So solve. So parallel means what is the formula? K equivalent parallel. Springs in parallel, capacitor in parallel. What is the formula? K1 plus K2. So 5K by 2 plus 5K by 3. Solve this. 5K common. 1 by 2 plus 1 by 3. How much? 5 by 6. So what is the answer? 25 by 6K. Okay. 25 by 6. Okay, clear? 25 by 6. Note down. 25K by 6. Are you getting or not? Correct? Check calculation. Calculation check. 1 by 2 plus 1 by 3. 5 by 6. So done. Finish. This spring is finished. Now next topic we are starting now. Note down next topic. So spring is finished. Now pseudo force will do. Note down. Next you write down. We can do average force or pseudo force. Which we should do? Tell me. Average force or pseudo force? Pseudo force. If pseudo force will do, elevator is also there. Elevator is there. Okay. More things are there. It is big chapter. Average force. Let's finish average force. Okay. Average force will do. Note down. Topic average force. Both are important only. After this friction. So note down. Topic you write down. Average force. Average force, impulse and momentum. Average force, momentum and impulse. See, suppose this is a football. Okay, this is a football. It is at rest. So what is the initial velocity? 0. This is a football at rest. Football at rest. Now this is a player. So player will kick this football. Correct? It will kick the football. So immediately after kick, in a very short time, football will attain speed 5 meter per second. So just before kick, what is the speed? Just before kick, what is the speed? 0. And after kick, what is the speed? 5 meter per second. Correct or not? Football is there. So contact came. Okay, shoes, legs, leg and football comes in contact. leg and football comes in contact. Are you getting? So how much is that time? Time of contact. What is the time of contact? Time of contact is how much? How much? How much contact time like this? Suppose here a football is there like this, you are hitting it. Contact time is how much? 1 second, 1 minute, 1 hour, or 1 millisecond? How much is 1 millisecond? 1/1000 second, correct? 10 millisecond, 10/1000 second, correct or not? So time of contact is more or less time of contact. Suppose player is coming like this, it will hit the football, so it will touch the football. The touch time, time of contact, how much? It is less or more? It is less, correct? Because immediately the player and the ball separate. Player will not go with ball, correct? Only ball is going. So what is the time of contact? It is in second or millisecond? Milliseconds. Okay. So when time of contact is very less, we can calculate average force. So what is the formula for average force? Delta P by delta T. What is P here? Momentum. P is the momentum. Okay. So what is the formula for final momentum? M into V2 vector and initial momentum M into V1 vector divided by time of contact delta T. Okay, so this is known as average force. So you can write down what is average force. When force acts for very short time, note down, when force acts for very short time, when force acts for very short time, momentum changes, momentum changes during that time. Momentum changes during that time. Okay. Before, when this football is there, before what is the speed of football? 0. Now player is coming running, it will hit the football. Just after hitting, what is the speed of football? 5 meter per second. So speed change, momentum change, velocity change, correct? Momentum change. So momentum changed. Okay, so momentum changes during that time. So that is known as time of contact. So generally time of contact is less. Okay, short time, very short time. So momentum changes in very short time. Momentum changes short time. So what is the formula for average force? Delta P by delta T. Okay, so we can calculate it. So suppose mass of football is 100 gram. Let's take mass is equal to 100 gram and time of contact is 1 millisecond. What is the average force? Tell me. So average force. Average force means delta P by delta T. Memorize this. Delta P by delta T. So what is the average force? M into V2 minus M into V1. MV2 minus MV1 divided by delta T. Mass is now convert in kg. 100 gram how much? In kg how much? 0.1. So 0.1 kg. So 0.1 V2 minus V1. What is V2 minus V1? V2 5. V1 0. Time taken 1 millisecond. 1 millisecond how much? 1/1000. Or you can say 10 raised to minus 3. 10 raised to minus 3. So tell me what is the answer? 10 raised to minus 3. How much? So this is 10 raised to minus 3. Take it to numerator. It will become 10 raised to 3. Correct? Into 5. Now 1000 into 0.1 how much? 100. So 100 into 5. So 500 Newton. 500 Newton. Okay, clear? So 500 Newton. So this ball, this is the ball. What is the direction of force on the ball? Right side. So the player will also experience force where? Left side. If player is hitting ball right side, so ball will also hit player left side. Are you getting? Suppose if you replace this ball, it is made up of plastic, right? Foam, correct? Mass of the ball is very less. What if you replace this football with a stone? Very heavy stone. It is looking like football. You paint it from outside. Outside you are painting it like football. And ask the player to go and hit the football. But inside it is a stone. What will happen? Injury will happen. Correct or not? So player will hit it. The stone will go little bit only. Little bit only stone will move. But player will be gone completely. Right or not? So that injury. Why? Because person is exerting force on ball. So ball is exerting force on person. Are you getting? Sometimes you see, suppose this is the person A and this is very small person B. You see sometimes A slap B. Suppose A slapping B. B is very strong. A is weak. A is weak. B is strong. A is weak. B is strong. A is slapping B. A slap B. Who get hurt most? Who get hurt most? Who get injury? A will get injury. Why? Because it is weak. But force on both will be same. Both experience same force. Both experience same force. Are you getting? Okay. So suppose A is hitting B. So B is also hitting A. Same force. But weak means it will more injury. Like truck and car. Suppose truck and car are colliding. Suppose this is truck and this is car. They are colliding. Which will have more damage? Car. So, but force is same. So force on truck due to car is same as force on car due to truck. Direction opposite. Okay. Direction is opposite. We can calculate it. Let's calculate. Let's solve one question. Suppose truck mass is 2000, 20,000 kg. Truck mass is 20,000 kg and car mass is 800 kg. Car mass is 800 kg. Initial velocity of truck is 30 meter per second. Initial velocity of car is say 40 meter per second. Now they are coming like this. Car is coming, truck is coming. They will collide. So what is the final velocity? Suppose 0. Final velocity suppose 0. Final velocity is suppose it is 0. Actually, maybe 0 may not be 0 because center of mass we have to consider. But I am giving final velocity 0. So what is the force on truck due to car and force on car due to truck? So change in momentum. What is change in momentum for truck? Delta P for truck. Tell me what is delta P for truck? Final 0. Initial MV, correct? So 20,000 into 30. And what is change in momentum for car? Change in momentum for car. What is final? 0. And what is initial? Negative. So 800 into minus 40. So minus minus plus. So 800 into 40. So what is the direction of change in momentum for car? Plus. What is the direction of change in momentum for truck? Minus. Are you getting or not? So truck is experiencing force where? Truck is experiencing force where? Right or left? Tell me. Left. Car is experiencing force where? Right. So delta P, you check the delta P. Delta P for truck is negative. Final velocity 0, initial velocity 30. So final 0, initial. Okay, this is P final minus P initial. So P final minus P initial. P final 0, P initial. So delta P for truck is what? Positive or negative? Negative. Delta P for car is positive or negative? Positive. So note down. So what is that? How will you find direction of force? Direction of average force. How to find direction of average force? See the direction of delta P. So average force is along delta P. Note down. This is the theory point. Note down. Average force is along delta P. Average force is along delta P vector. Average force is along delta P vector. Right now. Average force. Okay, clear? Average force. How to find direction of average force? Delta P. F is along delta P or opposite to delta P? F. Along. Okay, clear. Remember this. F is along delta P. Force is along delta P. So see, let's solve one more example. You take a ball. You take one ball, mass of ball is m, it is dropped. Suppose this ball is dropped from height h1. Ball is dropped from height h1 and this is the ground. So with what speed it will hit the ground, tell me? Square root of 2gh1. Very good. Now after hitting it will rebound. So suppose after rebound it is going to height h2. It will not go to same height. Less height it will go. What is the final velocity again? 0. So with what speed it is rebound? Square root of 2g h2. Are you getting? So what is changed? After hitting, what is changed? It is hitting the ground. What is changed after that? Direction. Direction change. Magnitude also changed. So momentum is changed. What is the direction of momentum before? Downward. What is the direction of momentum after? Upward. So momentum changed from negative to positive. Are you getting? So what is the average force? How to calculate average force? If ball comes in contact, if ball comes in contact for delta t seconds, if ball comes in contact for delta t seconds, are you getting or not? Why direction of ball is changed? Because it is hitting the floor. Okay, it is hitting the floor like this. So it is coming in contact. Without contact, ball cannot rebound. It will contact with the ground, then rebound. The time of contact is 1 second or 1 millisecond. It will more time or less time? Less time. Very short time. Very less time. The time of contact is very less. Contact time is very less. So what is delta P vector? Tell me. Final momentum. What is final momentum? Tell me. Mass into velocity. So m square root 2gh2 minus. And what is initial momentum? What is initial momentum? Downward. So negative minus m into square root of 2g h1. So this is m square root 2g square root h2 plus h1 square root h2 minus minus plus square root h1. Okay, so this is delta p vector. So what is the average force? What is the formula for average force? Delta p by delta t. So m under root 2g root h2 plus root h1 divided by delta g. Okay, you are releasing this ball from what height you are releasing? h1. To what height it is rebounding? h2. So what is the velocity of hitting? Square root of 2g h1. Rebound speed square root of 2g h2. And velocity, initial velocity downward negative, final velocity upward. So v2, what is v2 here? Plus square root 2g h1. What is v1? Minus square root 2g h1. Okay, clear? So this is the formula for average force. Okay, clear? Understood? Note down. Now solve one question. Note down. Mass of ball is given. So mass of ball 100 gram. Take h1 20 meter and h2 5 meter. Delta t 2 milliseconds. Find average force. Okay, calculate. So ball is dropped. Okay, you take a ball, you drop it. From what height you are dropping the ball? From what height? 20 meter. 20 meter ball is dropped. What height it is rebounding? 5 meter. Time of contact? 2 milliseconds. Okay, solve. You can solve using V1, V2 also. You can calculate V1, V2. Velocity of a strike. What is velocity of a strike? Velocity hitting. Hitting velocity. What is this? V1. Ball hits ground. So what is the velocity of, with what velocity it is hitting? Minus square root 2g h1. 2 into 10, g value you take 10, right? G is 10. G is 10. So what is V1? So minus under root 2gh h1. h1 20. 20 into 20, how much? 400. Square root of 400. Square root of 400, tell me. 20. So what is V1? Minus 20. V1 minus 20. Now calculate V2. V2. V2 will be plus or minus? Plus. So plus square root 2g h2. What height it is going? 5. Now 2 into 10 into 5. How much? 100. Square root of 100? 10. So the ball is hitting ground with what speed? 20. Rebounding with what speed? 10. Okay. So calculate impulse. So impulse you can calculate. Tell me what is the impulse? Impulse means change in momentum. Note down. I will teach impulse separately also. Just formula you write down. Impulse means change in momentum. M delta V. mv2 minus v1. Mass, what is the mass? 100 gram means 0.1 kg, right? Note down. Okay, any answer? Note down. 1 gram means 10 raised to minus 3 kg. Okay, 10 gram means, so 10 raised to minus 3 means 1 by 1000 kg, and 10 gram means 10 by 1000 kg, right? So 1 by 100, 1 by 100 means 0 0.01. 100 gram means 100 gram means 100 by 1000, 100 by 1000 kg. 100 by 1000 means 1 by 10, 1 by 10 kg means 0.1, 0.1 kg. So mass is 0.1, and what is V2? 10 minus, what is V1? Minus 20, minus 20. So 10 minus minus 20, how much? Plus 30, very good. So 0.1 into 30, 0.1 into 30, how much? 0.1 into 30, 3. So 3 impulse is 3 kg into meter per second, kg meter per second, kg meter per second. Okay, 3 kg meter per second. And what is average force? Average force is impulse upon time. So delta p you calculated. Delta p is 3, and time 2 milliseconds. 2 into 10 raised to minus 3. Okay, 1 millisecond. You know 1 millisecond how much? 1 millisecond means 10 raised to minus 3 second, or 1 by 1000 second. 1 by 1000 second. So 2 millisecond means 2 into 10 raised to minus 3. So 3 by 2 into this, it will go here, 10 raised to 3. So 3000 by 2, 1500. Okay, average force 1500 Newton. Okay, done. Or you can use direct formula here, you will get your answer, right? So mass is 0.1, 0.1. Time is 2 millisecond. So 2 by 1000, 2 by 1000, root 20, root h2 plus root h1. Okay. Root 5 plus root 20, root 5 plus root 20. Then take root 20 inside, same thing it is, you will get same answer. So average force. Okay, clear? Okay, now next, now you solve this very basic question. You solve bullet and gun. Note down. Bullet of mass, which is heavy? Bullet or gun, which is heavy? Bullet or gun, which is heavy? Gun. Gun is heavy. Bullet of mass 10 gram. Bullet of mass 10 gram is fired from gun of mass 1 kg. Bullet of mass 10 gram is fired from gun of mass 1 kg. Bullet has speed 720 kilometer per hour. Bullet speed is 720 kilometer per hour. It takes 0.1 millisecond. It takes 0.1 millisecond to travel through barrel of gun. Barrel of gun. Barrel means pipe. Pipe. Okay. Suppose this is the gun. Initially bullet is here. Now you fire the bullet. So some chemical reaction will go. The bullet will travel like this. Now this gun is finished. This is the end of the gun. Okay. So this is the start, end of the gun. Now bullet will come out. So with what velocity bullet come out? 720 kilometer per hour. What is the initial velocity of bullet here? Rest. So from 0 to 720, it is acquiring in this much time only, this much length only. So this is known as barrel. Okay, this is known as barrel of the gun. Note down. This is known as barrel of the gun. Okay. So what is the time taken? 0.1. Okay. So calculate force on the gun. Calculate force on the bullet and gun. Calculate average force on bullet. Calculate average force on gun. Okay, all values you write. Mass of the gun is mass of the bullet is given. Mass of the bullet. Okay, 10 gram. 10 into 10 power minus 3. Mass of the gun, capital M, 1 kg. Mass of the gun, 1 kg. Then mass of the bullet, 10 gram. Calculate recoil velocity of gun. Recoil velocity of gun. What is the direction of force on the bullet? Direction of force on the bullet. Bullet is experiencing force where? Right or left? Bullet. Huh? Right side. It is like throw. When you throw something, you're exerting force. Okay. So force on the bullet is right side. So what is the direction of force on the gun? Left side. This is the gun. So gun will experience force left side. So force on gun due to bullet, left side, and force on bullet due to gun, right side. Okay. So now calculate this. Calculate the force. First we calculate the force. Tell me. Now, so note down. Force on bullet due to gun is equal to change in momentum for bullet divided by delta T. So what is the change in momentum for bullet? What is the final momentum and initial momentum? So final momentum minus initial momentum. Okay. So final momentum tell me mass into final velocity minus mass into initial velocity. So mass is given, mass of bullet is this 10 into 10 plus 2 minus 3, V2 minus V1. Now convert in meter per second, 720 kilometer per hour, meter per second, how much? 720 into 5 by 18, how much? 720 by 80, how much? Cancel, 4 times, 40 into 5, how much? 200 meter per second, how much? 200 meter per second, correct? So final speed 200 minus initial speed 0. Time taken, what is time taken? 0.1 second. Millisecond. 0.1 millisecond, how much? 0.1 is 0.1 10 power minus 3. So What is the combined power? 10 power minus 4. So this is 10 power minus 4. So this is 10 power minus 2 by 10 power minus 4 into 200. 10 power minus 2 by 10 power minus 4. How much? 10 power minus 2 plus 4. So 10 power 2 into 200. So 2, how many zeros? 4 zeros. Okay. 20,000 Newton. 20,000 Newton. Note down. So force on the bullet due to gun is 20,000 Newton right side. So average force on bullet is 20,000 Newton right side. So what is average force on gun? Average force on gun? 22, correct. 20,000 left. Are you getting? Left. So minus 20,000 Newton. This is plus 20,000 Newton. Force on bullet is plus 20,000 Newton. Force on gun is minus 20,000 Newton. Okay. Now how to find recoil velocity of gun? So gun will also recoil backward. So one method is momentum conservation. I will teach that. Okay. But without that also we can solve. Now see, for gun, what is the initial velocity of gun? 0. Initial velocity is 0. Now gun is going left. Okay, gun will recoil left. Gun is recoiling left. When bullet is fired right side, gun will recoil left. Okay. So action reaction, you can call it action reaction. Bullet is action, force on bullet is action, so force on gun is reaction. So same force you can write. So what is the force on the gun? Minus 20,000. So minus 20,000 is equal to mass of the gun. So mass of the gun how much? 1 kg. Mass of the gun 1 kg into V2 minus V1. V1 is 0 by time taken. And time taken is correct 0.1 millisecond. So 10 raised to minus 4. So you have, now you solve. So minus 2 into 10 raised to 4 into 10 raised to minus 4. 10 raised to 4 into 10 raised to minus 4. Cancel. So what is the velocity of recoil velocity of gun? Minus 2. Okay. V2 is minus 2. Okay, done. So note down. So the bullet will acquire momentum right side, gun will acquire momentum left side. So this is known as action reaction. This is known as action reaction. Suppose there is a wall and this ball is coming, mass of the ball is m, it is coming with velocity u. It will hit the wall and suppose it is rebounding with velocity minus u. So what is the change in momentum? Tell me. 2 mu or minus 2 mu? Final minus initial. This is known as impulse. Okay. Impulse means change in momentum. You can note down impulse is change in momentum. Impulse is change in linear momentum. Okay. Change in linear momentum. So what is the final momentum? Tell me. Final momentum minus mu. What is initial momentum? Mu. So minus mu minus mu. So what is the change in momentum? Minus 2 mu. Are you getting? See, what is the formula for impulse? Change in momentum. Initially ball is going like this. After, like this. After rebound, it is going where? Left. Before going right. Now this is the wall. Okay, this is the fixed wall. Fixed wall. So hitting with velocity u, rebounding with velocity minus u. So what is the final velocity? Minus u. Okay. M into V2 minus V1. Use this. M into V2 minus V1. So M into V2. V2 is minus u minus V1 is u. So minus 2m u. Okay. How much is impulse? Minus 2m u. Okay, clear? Suppose ball is coming from right side. Now, suppose this is the wall. Ball is coming from right side with velocity u. Now it will rebound with velocity u right side. Now tell me what is impulse? Now tell me what is impulse? M into V2 minus V1. Tell me, calculate. M into V2 minus V1. What is V1? How much V1? V1 minus U. V2 plus U. So what is the answer? 2 mu. So in this case, impulse is positive or negative in this case? Negative. In this case, impulse is positive. Okay. So in this case, average force is positive or negative? Average force on the ball. Average force, what is the formula? Delta P by delta T. What is sign of delta P? Same sign for delta, same sign for force. Okay. Force is along impulse. Force is along impulse. What is the direction of impulse? First case. What is the direction of impulse? Positive or negative? Negative. Impulse is left side. So what is the force? Direction of force on ball? Left side. What is the direction of impulse? Second question. Right side. So what is the direction of force? Second question. Right side. So force on ball is right side. Force on ball is rightward. In this case, force on ball is leftward. Force on ball is leftward. Okay. So here, force on ball is left side. Here, force on ball is right side. Okay, clear? Understood? Now let's take one angle type question also. So suppose then we'll finish this average force. Suppose this is the wall. Ball is coming like this with velocity u. This angle is theta. And it is rebounding like this. Ball is rebounding like this with same speed, and this angle is theta. Okay. So you can call it angle of incidence, angle of reflection, like this you can call. At what angle of incidence ball is coming? Theta. At what angle it is rebounding? Theta. This is normal. You can call it normal. normal to wall. Okay, this is the wall. So now take components. So component perpendicular to wall, parallel to wall. What is the component parallel and perpendicular? What is this angle? Tell me this angle. Theta. So this component is u cos theta. This is u sin theta. Good. Now what is this? What is this angle? This is theta. So what is this angle? These two angles same, right? This is theta. So what is this? Theta. So what is the left component? U cos theta. Down component u sin theta. So y axis. This is y axis. This is y axis. This is x axis. Okay. Y axis, x axis. So any change in y component? What is the y component? Y component initially? U sin theta downward. What is the y component now? U sin theta downward. No change. So along y direction, impulse is 0. You can note down. So parallel to wall means along y direction. Parallel to wall along y direction. What is the impulse? Impulse is 0. Impulse is 0. No change. No change in momentum. No change in momentum means what is the force? What is the force along y direction? 0. Because parallel to wall, what is initial velocity? U sin theta downward. Parallel to wall, what is the final velocity? U sin theta downward. No change. So velocity no change, impulse no change. So what is the force parallel to wall? 0. So parallel to wall force is 0. Note down. Parallel to wall force is 0. Now x direction you take, x direction. What is it? What is velocity x direction before collision? Before impact? U cos theta, right side. Before impact, after impact, after impact. What is the x direction velocity after impact? Minus u cos theta. So perpendicular to wall. Note down. So perpendicular to wall. What is perpendicular to wall? What is the impulse? Tell me. That is x direction. Delta p x. How much impulse? M into v2 minus v1. What is final? Negative. Minus u cos theta minus initial plus u cos theta. So minus common. What is the final answer? Minus 2 mu cos theta. Good. Minus 2 mu cos theta. Delta p along x. So last point you write down, force. What is Fx? How much is Fx? Tell me. Fx. Fx. Minus 2 mu cos theta by delta t. What is delta t? Time of contact. Time of contact. Okay, ball is coming like this. Ball is coming like this. Hit the wall. Go like this. Okay. So initial velocity is like this. Final velocity like this. Okay, understood? Okay, done. So average force over. So okay, now you take break. So now pseudo force is there. We'll do tomorrow. Pseudo force and elevator also we'll do. Elevator, spring balance, weighing machine, apparent weight. Okay, weighing machine, apparent weight, weighing machine, elevator question, pseudo force, that car and string question, pseudo force. Then we'll do friction also. Friction also. Okay, today is Wednesday, right? Tuesday, Wednesday. Today. Huh? Wednesday. Okay, Thursday, Friday, Saturday also class. Okay, Saturday. 6:30 to onwards. 6:30 to okay 2 to 3 hours. Saturday. That uh, by Saturday we'll finish friction also. Next week, Tuesday, Wednesday, Thursday. Okay, banking we'll do. Banking of road, banking and circular motion, dynamics. Okay, circular motion, dynamics. So Tuesday, Thursday, then so Thursday, Friday, Saturday. We'll start work for energy also. Next week we'll start work for energy. Okay, clear? Understood? So before 30th August, we'll try to finish these all. Okay, done. Any doubt? Yes.